I have previously talked about entities, attributes, and relationships in the previous videos, but in this video we are going to talk about it in greater details. So, the basic constructs of the ER model are entities, attributes, and relationships. And if you have been faithful in watching the previous videos, these terms are not new to you anymore. So, the richness of the ER model allows designers to model real-world situations accurately and expressively, which helps account for the popularity of the model. The figure here is an example of an ER diagram. This depicts a customer, like you and me, making an online purchase from an online store, let us say Lazada or Shopee or Amazon. We will get into details later about this diagram here. This is just to show you a sample ER diagram. This is how a typical ER diagram would look like. Entities. An entity is a person, a place, an object, an event, or even a concept in the user environment about which the organization wishes to maintain data. Thus, an entity has a noun name. So, if you look at this sample diagram here, you will see customer or order. These are entities. A customer is an entity because it is an object of interest to the organization such as Lazada, Shopee, or Amazon. Another entity here is order. This is also important to the organizations such as Lazada or Shopee or Amazon because it is an event. And the organization wishes to maintain data. So, that is an example of an entity. The naming and defining of entity types. Number 1, an entity type is a singular noun such as customer or order, as you see here in our example. So, an entity name should always be singular, not customers or not orders. Okay? Next, an entity type name should be specific to the organization. So, thus, one organization may use the entity type name customer, and another organization may use the entity type name client. So, keep that in mind as well. And next, an entity type name should be concise, using a few words as possible. Attributes. Each entity has a set of attributes associated with it. For example, we have customer and order here. So, the attribute for a customer entity is customer ID and customer name. And let's look at order entity. It has two attributes and they are order ID and customer ID. Okay, so an attribute is a property or characteristic of an entity that is of interest to the organization. Thus, an attribute has a noun name. Let us look at the different types of attributes. Number 1, required versus optional attributes. An attribute that must always have a value is called a required attribute, and whereas an attribute that may not have a value is called an optional attribute. Let me show you an example. Here, I have an entity called student, and the attributes are student ID, student name, student date of birth, and student major. Now, in this case, student ID is a required attribute because a record of a student in the database cannot be stored without its student ID. That means a student named Dodong the record cannot be stored in this data set without the student ID S11. Where, for example, student name John, his ID number is S13, so it has to be present. Can never be empty, or it can never be void. That is what is called as a required attribute. Very simple, right? The next is called an optional attributes. Now, look at a student named John and his ID is S13. Look at his major. It's empty. Now, a student, especially in his first or second semester, may not have a major. They may not decide what they want to major in. So in this case, this attribute major can be empty. So in this case, a major may or may not be empty. That's it. Next, we have simple versus composite attributes. So, some attributes can be broken down into meaningful component parts. A common example is name attribute. And the other is a simple or atomic attribute. That cannot be broken down into smaller components that are meaningful for the organization. So, let me explain this using an example. Let me open up the student data set one more time, and here we have the student name. So, this student name will be a composite attribute because it can be broken down into mainly 3 different components. So let me do that. I add 2 more columns. Now I'm going to have the first name, middle name, and then surname. So that's better. Now in this case, the middle name can be empty. So the surname, okay, we will need to fill up the surname. One at a time. And yes. So we have, so in this case, you may have the first name and the surname as required attribute and the middle name as optional attribute. And remember, the major is also an optional attribute. So you may be wondering, how are you going to impose these rules? Well, in the future, after a while, we are going to learn how to design these databases using MySQL, and you will learn to impose these rules and regulations on MySQL using SQL, or the structured query language. Oh, by the way, I forgot to mention an example of an atomic attribute here. So student ID will be a typical example of an atomic attribute because it cannot be broken down any further. And it is also a required attribute. Let me quickly explain what MySQL is. It is a database software where all these databases may be stored. It is open source software. That means we don't have to pay for it. There are other databases in the market like Oracle, but they are not free, so we will not be using it for the purpose of our course. Now you may be wondering, what is SQL then? Well, SQL is a structured query language. That means SQL is a standard language for storing, manipulating, and retrieving data in databases. So, we will learn to use SQL in this course. There is something called stored versus derived attribute. I want you to carefully look at this student data set here. Look at the student date of birth attribute. Here I have the record of each birth date of each student. Now, this is called a stored attribute because I have the record of everyone's birth date. Now, later on, when we start using SQL, I will be able to calculate the age of every student in my list here. And the age will become a derived attribute. So I will show you that, and we will be dealing with that later. So a derived attribute is an attribute which will be the age of each student, whose values can be calculated from related attribute values, which is the student date of birth. So the student date of birth will be the stored attribute, and the age that we will derive or calculate from it will become a derived attribute. So we will do that using SQL later on.